Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. We often think of trees as stoic, static pillars of nature. Their movements are slow, measured in seasons or decades. But deep beneath the soil, where the real action happens, the story is far different. Scientists have uncovered a rapid, rhythmic movement in plant root systems so consistent and quick that they've dubbed it the tachycardia of trees, the fast heartbeat of the botanical world. This isn't a heart in the traditional sense, of course, but an analogy for a critical physiological phenomenon. The regular, minute-by-minute pulsing of root tips, driven not by light or water, but by an internal, molecular clock. We are talking about the circadian rhythm, the 24-hour cycle that governs sleep, wakefulness, and metabolism in nearly all life forms, finally revealed at the deepest level of plant architecture. For decades, botanists knew roots grew, responding primarily to gravity, gravitropism, and water, hydrotropism. But thanks to advances in microscopy and time-lapse imaging, researchers can now peer into the dark theater of the soil with unprecedented clarity. What they found shattered the image of the slowly growing root. Root tips, the engine rooms of growth and nutrient absorption, don't just push steadily forward. They oscillate. They pulse. In some species, these movements, which involve subtle shifts in growth direction and elongation speed, occur every few minutes. This rapid rhythm, the tachycardia, is governed by genetic expression cycles that precisely tick on a 24-hour schedule. So, why the pulse? Why is this rapid, rhythmic action so essential that it's hardwired into the plant's internal clock, even if the root is buried hundreds of feet away from the sun? The answer lies in efficiency and optimization. The soil environment is incredibly complex, a patchy, heterogeneous matrix of water pockets, nutrient clusters, microbial activity, and air gaps. A root that simply pushes forward risks wasting energy on unproductive paths. The rhythmic pulsing allows the root tip to constantly scan, probe, and optimize its trajectory. Think of it less like a blind drill and more like an active, searching probe. When the rhythm is optimized by the internal circadian clock, the plant can coordinate its nutrient uptake mechanisms with its movement. This ensures maximum metabolic efficiency. The plant anticipates the best time of day to invest heavily in root exploration, aligning internal resource allocation, like the transport of vital hormones and sugars manufactured in the leaves, with the physical mechanism of growth below. One of the most fascinating aspects of this discovery is that the rhythm is endogenous. It persists even when plants are grown in complete, constant darkness under uniform humidity and temperature. This proves that the timing is not a mere reaction to external cues, but a fundamental biological imperative. Researchers have found that the expression of key clock genes, such as LHY and TOC1, directly correlates with the peaks and troughs of root elongation speed. When scientists genetically disrupt these clock genes, the root growth becomes erratic, non-rhythmic, and, critically, less efficient at foraging for resources. The implications of understanding the root's circadian rhythm are enormous, especially in the face of climate change. If we can identify the specific genetic pathways that fine-tune this root tachycardia, we open the door to developing crop varieties with optimized root systems. Imagine rice or wheat engineered to maximize nutrient uptake during specific 12-hour windows, reducing the need for excessive fertilizer application. Or consider trees planted in drought-prone areas, whose roots are timed to aggressively search for deeply buried water reservoirs during cooler nighttime hours. This is the frontier of chronobiology applied to botany. It shifts the paradigm from viewing plants as passive resource takers to recognizing them as active, time-aware organisms constantly making micro-decisions based on their internal rhythm. The tachycardia of trees reminds us that the fundamental laws of life, the necessity of a reliable internal clock, extend deep into the earth. The rhythm of life is not just in our hearts or our sleep cycles, but in the rapid, hidden pulses of the roots holding up our world. Understanding this secret heartbeat is crucial to ensuring the resilience of our forests and the productivity of our future agriculture. For more incredible facts like this, don't forget to subscribe and turn on notifications.